What you got there, Lucy?
A controller.
What's it controlling?
The TV.
Really? Whoa. Hey, you're not tricking us, are you? Do you have a controller? It's working. It's working. Hey, this is Alex. Welcome back to the project. As you just saw, we have a working prototype. I'm going to take this video to explain the basics of the wireless link. Let's get into it. Do you remember in the first video when I said,
but to be honest, I'm not sure how much of the SDK I will actually be using. I kind of prefer to use peripherals directly.
Well, I may have jumped the gun just a little bit. Once I had the non-wireless part of the project finished, I moved on to the wireless part. I opened up the datasheet, and I found an absolute mountain of registers to sort through. In the radio section, there were 174 registers. Just as a comparison, the PWM and the timer peripherals each had 49 registers, and I was comfortable working with those. But this radio section was a whole different beast. Now, don't get me wrong, I love digging into the nitty-gritty of the microcontroller's inner workings, as you've already seen, and I had a lot of fun with the PWM and timer and GPIO TE registers. But sometimes the level of detail is prohibitive to progress. So unless I want to make understanding the radio peripheral my full-time hobby for the next full year, I'll have to use the API and just accept some level of ignorance. My first iteration of the project 10 years ago used this NRF24 chip, which was a wireless transceiver. And basically, with minimal configuration, all you did was send the data that you wanted to transmit, and then it would alert you if any data was received. This is called enhanced shock burst, and it was baked into the chip. And this was perfect for doing simple communication like what I was doing with the N64 controller, sending small packets of data back and forth. Nordic ported the same functionality over to the NRF Connect SDK in an API, and it makes the wireless link trivial. It's got functions for initialization, reading and writing the payloads, starting the transmission and reception, and so on, which means that we don't have to get into the weeds of the registers to make something work, and that is going to save us time and effort. Okay, let's jump over to the whiteboard to see how our prototype is actually working. So here's what's going on behind the scenes. The console connected device learns the console's nominal polling rate, and depending on the game, it's either like 16 milliseconds nominally or 32 milliseconds nominally. So it learns this up front, and then a few milliseconds before the next expected request, the console device will send a request to the controller device with the wireless link to poll the controller. And the controller will send some acknowledgement back to say, hey, I received the message. The controller connected device then starts polling the controller to get the button data. It stores that button data, and then when the console device sends the next request, the request to send button data, the controller device automatically sends the button data that it saved back with its acknowledgement. And then the console device loads the button data into its memory so that when the console sends its polling request, the console connected device will generate the appropriate PWM signal that matches the buttons that it just received. This is a capture of Super Mario 64 with our working controller. And we'll zoom in here. On the top, we've got the controller connected device. On this red trace, we've got the console connected device. And you can see about every 32 or so milliseconds, we get the console requests, and then the console device sends the data. So these little blips here indicate when the radio transmission and reception are happening. So here the console device sends its message, and here the controller device successfully receives the message, and immediately following the reception, it will pull the controller and then save its data. This happens about 4 milliseconds before the expected console request. And then, about 3 milliseconds before the expected console request, about a millisecond after the first request, the console connected device will send another message to say, "Send me the button data." Controller connected device receives that message and then sends its button data. And then by the time we get here, the console connected device has the latest button data, and it will generate the appropriate signal after it decodes the console request. Pretty straightforward, right? Easy peasy. There's a lot more to do with the software, but now that we've proven the concept, we can move on to more of the fun parts of this project. The circuit board, the mechanical design. In the next episode, we are going to shrink this giant development board down into a custom PCB. Stay tuned. See you in the next one.